Hi, this is Jason Baker, and welcome back to our lecture. The next topic, and really the final topic of this lecture, is AWS CloudFormation. CloudFormation is an infrastructure definition tool that we use to create and manage AWS resources. It allows us to automate the deployment of these resources in the AWS cloud. You've already used CloudFormation a little bit in this course to launch a stack and delete a stack. What you may not realize is that many different AWS services actually use CloudFormation under the hood. Services like Elastic Beanstalk and ECS use CloudFormation to automate infrastructure. And, so these are managed services that you don't have to really worry about the underlying infrastructure. But AWS is using its own infrastructure definition tool to manage infrastructure components. CloudFormation uses a template file, and that template file describes the resources that need to be configured on AWS. These template files are written in either JSON or YAML format. Originally, when CloudFormation was launched, they only supported JSON, but more recently, they are also supporting YAML. CloudFormation supports infrastructure as code practices because you can take these template files and store them in version control systems like Git. You can set up automated testing pipelines to test the infrastructure. And because the infrastructure is defined in code within the template, you can repeatedly create infrastructure architectures. When you launch a CloudFormation template, the template is defining a set of resources called a stack. So a CloudFormation stack is the set of AWS resources that are created by the CloudFormation template. And the way it works is CloudFormation reads in the template definition, reads in the code from that template file, and then it makes a series of API calls to AWS. When it makes the API calls to AWS, it's using your permissions essentially. So like if you log into AWS and you launch a CloudFormation template, and that template goes off and creates a bunch of resources, your credentials are being used to create those resources, meaning that you have to have permission to do things like create EC2 instances and ELBs and security groups, VPCs, and so on. So CloudFormation, so the way this works is that you start by creating a CloudFormation template, either in JSON or YAML. Then you will store that template. You can save it to your local file system, but ultimately that template has to be stored in an S3 bucket. You then create a stack, a CloudFormation stack, by launching a new stack and specifying that template file that you created, which is stored in S3. CloudFormation then will provision all of the resources in that template, and it will provide you with some feedback and a report on its progress. And then once it's completed, it'll let you know that it has completed the creation of the stack and all the components within it. A CloudFormation template file contains multiple sections, and this slide shows you all of the different sections which are available, starting with the AWS template formation version, a description, there's a metadata section, parameters, mappings, conditions, resources, and outputs. Some of these sections are required, but actually most of them are not. Most of these sections are actually optional. And we'll go through each section and I'll help you understand the purpose of the section and whether it's required or not. Let's start with the parameters section. I mentioned earlier in the lecture that most infrastructure definition tools allow you to describe parameters for a template file. And a parameter allows you to supply input parameters into the configuration when you're launching a stack. And that's really useful because you can sort of create this generic stack that is used to create multiple environments, like a test environment and a production environment. And by changing the value of the input parameters, you can create sort of different environments with slightly different configuration. So when you're creating parameters, you define those parameters in the parameters section. Each parameter has a logical name, and the logical names must all be unique. When you define the parameter name, you also will specify some properties like the type of the parameter, which you can think of as like a variable type. But there are a couple different types that are supported: strings, numbers. There's a list type, and then there's an AWS specific type. There are a maximum of 60 parameters that are allowed in a template. And that's an awful lot of parameters. I think probably the most complex template I've ever written probably has on the order of, say, 25 parameters in it. When you want to reference parameters within a template, you use what's called the ref function. And I'll show you how that works in this lecture. Here's an example of a parameters section. This is written in JSON format. A parameters section in the template document. It starts with parameters and it defines a parameter object. And the parameter object has, each parameter will have a logical ID, a logical name, basically. And then the parameter will be assigned a type, which is a data type, such as a string. And then you might have a set of parameter properties, which are key values. Everything in the red here is something that you would modify within the template. When you are setting parameter properties, there's a number of really useful properties that you can select from. For example, you could specify a list of allowed values for the parameter. You could specify a default. That's very common. If the user that's launching a stack using the template doesn't provide a value for an input parameter, then you can automatically set that parameter to a default value. You can provide a description for the parameter, which is very helpful. And then you can set up constraints. You can set up like a max length or min length, max value, minimum value for the parameter. This is useful if you have a parameter which is something like, let's say, a number, and that number has to be within a specified range. And then finally, there's this no echo parameter property, and that's a parameter that you would use on if you were asking someone to input something like a secret, like a password value, because the parameter values are also stored in the output logs that the CloudFormation generated the stack and it produces a set of output logs, and those contain the parameter values that were input. generally you wouldn't want the value of a secret to be located in those output logs. And so the no echo property tells CloudFormation to basically hide that parameter value from the output logs. Here's an example of a parameter section in a real document. We have the parameter section, and we have a parameter, which is the name of which is instance type parameter. That's just a name that I made up. This could be any logical name that you want, as long as it's unique within this document. This parameter is a string. That's the type of the parameter. And it has a default value set, which is T2 micro. If the user doesn't provide a value, then CloudFormation will default to using this value. The allowed values property specifies a list. So if the user provides a value for this parameter, it must be one of these values from this list. And then finally, there's a description, which tells the user what the purpose of this particular parameter is. And then later on in the resources section of our document, we haven't gotten to the resources section yet, but I just wanted to show you how this parameter might be used. In the resources section, here I'm defining a new resource called an EC2 instance. And in the properties of that instance, I'm describing the instance type, which you know from working with EC2, there's all kinds of instance types. We oftentimes use T2 micros, but then there's there's like M4 and M5 and C4 and R3s and all kinds of different instances. In this instance type, for the value, we are referencing. That's what this ref function. So we're referencing this parameter. So we're referring to the parameter by its logical name. This reference, everything here in the curly brackets, this reference function will replace this with the actual value of this parameter within the template. So if we don't provide any value for the instance type parameter, it uses the default value, which is T2 micro, and then it will create an EC2 instance, which is using a T2 micro instance type. That was the parameters section. Next is the outputs section. And this I should have mentioned that the parameter section is an optional section. It's one that we almost always use, but it's not required. The outputs section is also an optional section of the template document. And the output section declares the values that the CloudFormation will return when the stack is created. So you can think of these as being, think of it as like a function call. When you call a function in your code, you're providing that function with input parameters. And that function then can also return a value or a list of values. Think of the outputs section like a function return, where our CloudFormation stack can output some values. And it's really convenient because CloudFormation can go out and create different resources, and those resources might have things like endpoint addresses, and they might have like actual like physical resource IDs and so on, properties that would be really useful to know. And you wouldn't have any way of knowing those in advance because they're sort of randomly generated by AWS. So we can take those outputs and we can define them as outputs within the output section, so we can view them conveniently after the stack is launched. You can you can output up to 60 different outputs on a template, and you can view these outputs either by looking at the web dashboard, the CloudFormation web dashboard, or there's also an API call that you can use to view the outputs from a CloudFormation stack. The value of an output can be several different things. It could be like a literal value. It could be a parameter reference like we just saw a moment ago where we were referencing a parameter. It can be something called a pseudo parameter or an intrinsic function, which we'll talk about in a bit. Now, here's an example of the outputs section of the template. You have outputs, which is wrapping an object, and each output has a logical idea, which is a logical name, a description, and then a value. And in the value, we specify the value that the output should reference. And this value is almost always dynamically generated. It's always based on some sort of parameter reference or some sort of function. It'd be very uncommon for this to be a literal static value. Here's an example of an outputs section, and this output section has two outputs. One is called backup load balancer DNS name, and the other output is called instance ID. The backup load balancer DNS name has a description. That's the DNS name of the load balancer. This is like the DNS endpoint for that load balancer, and we're specifying the value using a function call, and we'll learn about functions here in a bit. But this is basically retrieving an attribute, getting an attribute from that AWS resource, and the attribute we want is its DNS name. And so that is what is going to be output there. And the instance ID is referring to an EC2 instance, and it's grabbing the EC2 instance ID associated with that instance and also outputting that for us. Very, very helpful, very common. Pretty much every template I create uses input parameters and has some sort of output section. Even if I don't necessarily immediately use all these outputs, I generally create the outputs anyways, just assuming that at some point in the future I'm probably going to want to use them for something. Okay. CloudFormation templates CloudFormation templates aren't just static. You can do certain things inside the templates which are almost like programming, right? So you can do things like we can do conditionals. We can also execute functions within the template. And CloudFormation supports several different types of built-in functions to help you create more complicated stacks. You can use conditional functions that allow you to build if-then-else type structures. You can use lookup functions to kind of retrieve information from AWS. And you of course, you can use these intrinsic functions to retrieve data and reference data from things like parameters. Now, intrinsic functions is not a specific section of the template. It's not like the parameters and the output section or the resources section. Intrinsic functions are found in various, sort of sprinkled throughout various parts of the template, but they're mostly found in the resource section. Here's an example where In our properties section of our template, we have a property called my load balancer DNS name, and it references a function called getAt, which is a get attribute. You see the function starts with capital F, lowercase n, and then two colons followed by the function name. This is the syntax, the way you call a function, and then in between square brackets you have the resource ID name, and then you have the attribute that you want to get that's associated with that particular resource. There are lots and lots of different functions available. I'm not going to cover all of them in the lecture. You can certainly look to the CloudFormation documentation to see an exhaustive list. But these are some of the more interesting functions, and these are functions that you will likely encounter in this course. The first function is a function called base64, and the base64 function converts a string into its base64 representation. And really the only time I ever use this particular function is when I want to define user data for an EC2 instance. What you don't realize is that behind the scenes, when that user data is defined and it's passed to the EC2 instance via the API, it has to be that text information has to be passed in base64 format. If you're just using the website console and you're typing in the user data information there as part of your EC2 instance configuration, you don't realize that behind the scenes this is getting converted. When you're providing user data in a CloudFormation template, then you have to explicitly specify that the user data script is going to be converted to base64, and use that using this base64 function. The find and map function allows you to set up a dictionary object and then perform a value lookup based upon a key that you provide. And this is a really interesting function which helps us to make templates that work across different regions within AWS. And we'll look at an example in more detail here shortly. But that's also something to keep in mind, is that when you are launching a CloudFormation stack, that stack is being launched in a specific region, and it's the region that you're currently working in. It's important to when you're coding the CloudFormation template, it's important to make sure that you're writing and creating a template which can be launched in multiple regions. And that's trickier than it sounds. Think of like if your template defines an EC2 instance, that EC2 instance is going to be associated with an AMI. Well, AMIs are region specific. So you would need to be able to write a template that you can launch in both US East 1 and say US West 1. But if you launch it in US West 1, it would use a different AMI ID than if you launched it in US East 1. The find and map function allows you to set up dictionaries and map regions to a specific AMI so that your template is more portable. The getAt function is really commonly used. It allows us to get the value of an attribute from a resource in the template. And we use this all the time to get attribute informations from different resources. Oftentimes we're providing these as outputs. Sometimes we're providing these as part of a property when we're creating some other resource in the template. The getAz's function returns an array that contains a list of availability zones for the region in which you're launching the CloudFormation template. So for example, if you're launching the template in US East 1, then you could use this function here, get AZs, US East 1, and this function will return a set of the availability zones within that region. Now, instead of just sort of statically typing in US East 1, you can also use the ref function to reference something called a pseudo parameter, which we'll learn about in a bit. This pseudo parameter, AWS : region, will return the value of the region in which the template is currently being launched. So if you launch this template in US East 1, then this reference call will return US East 1, and then this get AZs function will execute based on that value and return the same thing as this first function call. A couple more intrinsic functions to walk through here. The join function allows us to concatenate a set of values into a single value, and then the concatenated values can be delimited by an optional delimiter that we specify. Here's an example where we're using the join function, and we're joining together a set of values, A, B, and C, a set of strings, and we're using the colon character as a delimiter. When we run this function, it will return this string, a single string, A:, B:, C. Very, very useful function that provides concatenation. The select function will return a single object from a list of objects. You can think of this as like, if you're working with a positional array and you want to return the value of a specific element of an array. In this case, we want to select value 1 from this list, apples, grapes, oranges, and mangoes. And this returns grapes. The first value is 0. So this is position 0, 1, 2, and 3. So this is like, grabbing the first position from a list. Returns grapes. The ref function, which we've already seen a number of times, allows us to return the value of some parameter or some resource that we specify. We use the ref. Notice that this isn't prefixed by the function : We just need to use ref here. It's sort of a shorter way to use this function. And then we have condition functions. The condition functions allow us to set up conditional structures like if, then, else type structures. And we can use these conditional structures to conditionally create resources. Why would you want to conditionally create resources? Well, maybe you've created a template that you're going to use for both development and production. But when the template is used for production, you want it to maybe launch a couple additional resources which are not found in your development environment. Well, you can do that by using these condition functions. The first example here is we have an equals function, and we're comparing two values to see if they're equal. And if they are, then this function will evaluate to true. The section function performs an if. It creates sort of an if structure. And in this case, we have if we specify a condition name, and then the value that this function should return if the condition evaluates to true. Otherwise, if the condition evaluates to false, then we should return this value, the value of false. Here's an example. We have a function, if function here, that has a condition name, which is production. And this production is defined somewhere else within our document. And production is basically, think of it as like a parameter that's going to evaluate to true or false. If it's true, then this function will return the value m3x large. If it's false, it will return the value T2 micro. This is likely for like a development environment where a large instance type is not required. Okay, so again, that's not an exhaustive list of functions that are available. There's several more that are available to you, and I encourage you to look at the CloudFormation documentation to learn more. CloudFormation also allows us to use pseudo parameters. We looked at parameters earlier, these input parameters that we can define. Pseudo parameters are a set of predefined parameters that CloudFormation provides to us. And there are a number of these parameters which are very useful. For example, and they all start with AWS : and then some name. AWS, the account ID, returns the AWS account ID in which the stack was created. Basically, the ID for your account. Let's see, you can return a no-op value. There are times when you might not want CloudFormation to do anything. Like we saw that if then else function where, if the property evaluated to true, then do this. There are some cases where like if the property evaluates to false, we don't want CloudFormation to do anything. But we have to put something in there as sort of a placeholder. And so we can use this AWS no value as a no op. AWS region returns a string which represents the AWS region in which the CloudFormation stack was launched. This is really commonly used, and we would use this pseudo parameter anytime we want to ensure that our template can be used across multiple regions. AWS stack ID returns the ID of the CloudFormation stack, and stack name returns the name of the stack. I use stack name quite a bit because oftentimes what I will do is I'll create tags for the resources in the AWS template or CloudFormation template. And when one of the tags I typically create for a resource is the name of the CloudFormation stack which created that resource. The CloudFormation template includes a section called mappings, and within the mapping section, you can define keys that map to different sets of named values. And this is really useful if you want to set up a template that will work across multiple regions. That's probably the primary use case. So in the mapping, the mapping that you set up is used in combination with the find and map function, and that allows you to find a value in the mapping based on the key. Here's an example of the mappings section. This mapping section has one mapping called mapping 01. And this mapping has two keys, key 01 and key 02. Each key is associated with a key value pair. And if we look at this example, this will make it a little bit more clear to you. Again, here's my mapping section, and I have a single mapping called a region map. This region map has a number of keys. You see these are different AWS regions like US East 1, US West 1, and then uh, Europe West 1, we have Asia Pacific Southeast 1, Asia Pacific Northeast 1. And each region has two pairs of keys or key values. It has a key of 32 with this AMI value and a key of 64 with this AMI value. So each key in the map is associated with multiple key value pairs. In the resources section of our template, then, we can refer to this map using the find and map function. Ultimately, what this find and map function is going to do is it's going to return a single value, a single string value. So the find and map function will call the region map, which is defined in our mappings section. And when it calls that map, it's going to look for a key, which in this case is based on the pseudo parameter AWS region. If we're running this template in US East 1, then the find and map function will map the call to the US East 1 key. And then finally, we're providing the sort of sub key within that key, which is 32, which is here. The find and map function then will return the value associated with this subkey, which is this AMI right here. This allows us to launch this CloudFormation template in different regions. And depending on the region that the template is launched into, it will define a different AMI for the EC2 instance. Because remember, the AMI ID is only specific to one particular region. If you want to use an AMI in another region, you have to actually make a copy of that AMI to another region. And when that AMI is copied, it gets a new AMI ID, which is completely different. So you have to track all these different AMIs, and you can use the mapping section to generate a map, and then use the find and map function to map the proper value to a resource property. So very, very useful function and very useful section. Okay, the next section is the conditions section. And the conditions section of the template allows us to control the creation of resources. And we use this to sort of manipulate and modify how we're defining different properties and creating different resources. When you create conditions, you define them in the conditions section of the template, and then you apply these conditions to different resources. A condition must evaluate true in order for a resource to get built. If the condition evaluates to false, then CloudFormation will just skip over that resource. Let's look and see how this works. We have a parameter section here at the top, and the parameter section defines an input parameter called env type. It stands for environment type, which is a string value, the default of which is dev. You can either type in prod or dev. Those are the allowed values. And then we define in a conditions section of the template a condition called create prod resources. And the value of create prod resources depends on the output of this equals function. What this equals function is doing is it's checking to see if the environment type is prod. If the environment type, that input parameter value, is prod, then the create prod resources condition is true. Otherwise, if the value of the environment type input parameter is dev, then the create prod resources condition will evaluate to false. Then down in the resources section of our document, we have a resource called mount point. And this mount point resource has a condition property associated with it. And the condition property references this create prod resources property. If this prod resources property evaluates to true, then CloudFormation will create this resource. Otherwise, it will skip it. That's really all there's to it when it comes to setting up conditions. They're very easy to use and extremely, extremely helpful because, again, this allows us to take a sort of generic template and tailor it for different types of environments. Okay, the resources section of the document is probably the most important part of the document. The resources document describes all of the different AWS resources that we want the stack to build for us. Everything from VPCs to subnets, security groups, IAM policies, EC2 instances, RDS instances. I mean, everything. Everything is defined in that resource section. And this is the only required section of the template. So like all these other template sections I've been talking about so far, these are optional sections. This is really the only required section that must be in that template. The resources section begins with the resources name, and it defines an object. And then we have a list, a set of resources. Each resource has a logical ID, a logical name basically. And then each resource has a resource type. And each resource has a set of properties, which are defined within a properties object. The one interesting property that you can associate with a resource is what we call the depends on attribute. And the depends on attribute allows you to specify a resource. It allows you to specify that a resource depends on some other resource in the template. In other words, you're telling CloudFormation that it needs to create some other resource before it creates the resource which the depends on associate attribute is associated with. Now, CloudFormation uses a declarative approach. We're basically declaring the resources that we want CloudFormation to create. We're specifying the desired state of our environment, and it's up to CloudFormation to really, figure out the order in which it should create resources. It knows, for example, that it needs to create a VPC before it creates the subnets that are associated with the VPC. Just makes logical sense, right? CloudFormation is able to figure that out on its own. There are some cases, however, where we specifically and explicitly want CloudFormation to create certain resources before other resources. And that's where we would use this depends on attribute to make sure that CloudFormation is creating resources in a particular order. There are multiple ways that we define properties for a resource. We can use string values, we can use numbers, we can use lists. Of course, we can use booleans, we can use like parameter references. You've seen a couple examples of parameter references. And we can also use functions. You've seen some examples of functions as well. Here's an example of a resource section within our CloudFormation template. This resource, we're defining a resource called Web1. That's the logical name. The resource has a type, which is AWS : EC2 : instance. This is a specific resource type. How do you know the resource type that you should use in the template? Because there are like dozens and dozens of different resource types. Well, you've basically got to go look at the CloudFormation documentation. And that documentation will show you a long list of all the different types of resources that you can create. And it'll give you the value for this particular attribute. And then we have the properties section of the resource. All of this is the properties section. The first property is the user data. Here we are providing user data for this EC2 instance that we want to create. And remember, this user data has to be encoded in base 64 format. So we're using the base 64 function, and we're essentially passing it in some user data information. This is using the join function to concatenate some string values. In this case, we have a string q equals, and then the value of this parameter. We have an availability zone parameter and an image ID parameter, our property, excuse me, image ID property. How do you know the names of these properties? Well, just like the type, you got to go look at CloudFormation documentation. Every CloudFormation resource type has a whole set of properties that you can define. And you have to just simply dive into the documentation to look at the different properties you can define for these resources and understand the purpose of the property and what the allowed values are. Here's another example of a resource where we are creating a queue, an SQS queue called myQueue. The type is AWS SQS queue. In this case, we're not specifying any properties. There probably are a bunch of properties we could specify here, such as a tag or something, but in this case, it's just empty. Oftentimes, most of the properties are optional. There are usually a few cases where some of the properties are absolutely required. So you just have to look at the resource type and look at the documentation to understand what properties are required and which ones are optional. Okay, so we've walked through most of the key important sections of the CloudFormation template. There are a couple other sections that I didn't cover, sections like metadata and so on. Those that you don't need to use for this course, but you're welcome to look those up in the documentation to learn more. Now, when you're creating CloudFormation stacks, there comes a time when your stack might get to be very large. Maybe you've got 100 or so resources that you're defining in your stack, and your stack file is now like 1,000 lines of code, and it can be kind of difficult to navigate and understand all the resources that are being created by a stack. So oftentimes what you'll do is you'll break stacks into smaller pieces, and then you will nest stacks. So you can have a parent stack which calls one or more child stacks, and you can use this nesting functionality to launch multiple substacks. And it's convenient. It's a way to break up a stack into multiple subcomponents. One thing that I should note about CloudFormation, which I hadn't talked about earlier, is that when you launch a CloudFormation stack, CloudFormation is not storing or maintaining any configuration state. So it's not like storing configuration state in an S3 bucket. It's not, you're not downloading configuration state onto your local workstation. So once the CloudFormation stack launches and it creates the resources, those resources are running in AWS. And it's almost like CloudFormation forgets all about that stack. It doesn't really know or understand the state of those resources after it's launched those resources. When you come back later, you can update your stack. So you can make changes to your stack template file and then apply an update to your CloudFormation stack. When you apply an update to the stack, what CloudFormation will do is it will go out and it will determine the current state of all the resources in your stack. And it will compare the state of those resources to the update that you want to make. And based on the difference, it'll create a what's called a change set, a configuration change set, and it will describe to you the changes that it's going to make to that stack. When you're working with CloudFormation, it's good to keep in mind a number of what I call best practices, or at least common conventions. The stack template files, you should be versioning these in some sort of source control system like Git. Also, when you're first starting to work and build a new stack and you're building a new template, generally you shouldn't try to start building a template from scratch. I never do that. I always kind of take one of my existing templates and I make modifications to it and pull out the things I don't need, and I add new resources. Well, where do you start from? Well, you can go out and there's all kinds of sample templates that are available from AWS and in different parts of the internet, and you can use those templates as a starting point for your own. Again, I don't recommend starting from like literally an empty template. Use an existing template as the scaffolding to create your new template. And then the templates that you create, you should be thinking in terms of reusability. Just like the applications that you build code libraries. Think of these templates as almost like libraries. You want to design them so that they're reusable, and you can use them across multiple projects. If you are going to use nesting within your templates, then I don't recommend nesting your templates more than one level. Technically, it's possible to do multiple levels of nesting, but that quickly becomes really complicated. And if you have something that complex, then it probably means that you need to take a step back and try to figure out how to simplify your template. You should use parameters, input parameters liberally in your template, and you use them to specify things like the environment or instance types, instance names, and so on. Anytime you're hard coding values into your template, any kind of static value, then you should take a step back and try to think about how you might use an input parameter instead of that static value. When you're creating resources within your template, you should be using tags. You should be defining a tag property on all of your resources. Remember, tags are really important, especially when you're working with an organization. You have different departments and teams and projects and so on. You need some way to keep track of all the resources that you're creating. And tags are the mechanism that we use in AWS to track our resources. And then finally, when you're creating CloudFormation templates, oftentimes you might be creating things like database resources. One of the things you got to be careful about is that when you're updating an existing CloudFormation stack, you might apply some sort of change which would cause the recreation of an EC2 instance or something like an RDS instance. So it would, like the CloudFormation stack would literally blow away your existing infrastructure and recreate it so that um, it aligns with your new desired state. So you could inadvertently blow away important resources if you're not careful. And so one of the things you should consider is that if there are important assets and resources like databases, make sure you have a snapshot of those databases before you apply an update with the template, just so that if you inadvertently blow something away, you're able to recover it. Now there are ways, and you can learn more by reading through the CloudFormation documentation. There are ways to protect resources so that you don't inadvertently blow them away by making changes to a CloudFormation template. And you do that by creating something called a stack policy. Um, I'll kind of wrap things up by talking about CloudFormation Designer. When I build CloudFormation templates, I'm using a code editor. I'm using something like Visual Studio Code or Atom, whatever text editor I have at hand, maybe VI. I'm creating all of this code by hand. AWS provides a graphical tool called CloudFormation Designer, which you can use to create and edit CloudFormation templates. This is a web-based tool. And so in the way they sort of market this tool is that it's sort of like an easy WYSIWYG way, graphical way to design CloudFormation templates, to design stacks. The CloudFormation Designer outputs JSON code or YAML code. So it actually outputs all of the code that you need in the template. And if you're interested, you can go off and try it and give it a spin. In previous semesters of this course, I have oftentimes demoed CloudFormation Designer, and we've used it a little bit. The truth is, I never use it in practice, and so while I can use the tool, it's not something I'm real comfortable using. And honestly, I find it way easier to build a template by hand than to try to use some sort of graphical tool and drag lines and try to connect things together. You can try it and see what you think. Personally, I don't find it very useful, and I don't go through any sort of hands-on demonstration of CloudFormation and Designer in this course anymore.